Great. Thanks, Rob. Thanks, everyone, for the opportunity. I had to step in here at short notice in place of a colleague who's far away right now. I'm Vasiliadis with the University of Chicago, and I work on this Globus project that Rob mentioned. So moving data is sort of at the core of what we do, but I'll talk more broadly about what Globus can do in the course of the whole life cycle of managing research data at scale. Before I move on, just a fair warning that we might get a little unsolicited contributions here now and then. Hopefully we'll be fairly quiet. So Globus is the service that we built at the university, and it's really intended to help scientists with data management problems throughout the life cycle, and doing so in a sustainable way. You can check out the website as far as the sustainability side goes. I'm really going to focus on, and this is just a snapshot of, the deployments that we have out there. So it's fairly widely used among nonprofit research institutions, certainly throughout the DOE labs and many other folks. So I'm going to give you a perspective from sort of what an typical end user might see if they just come along to the website and point and click and do things with Globus. So as Rob said, a lot of what we do is move data around. So we have a managed file transfer service. For those not familiar with that term, it basically means that the Globus service acts as a third party managing a transfer, managing the movement of data between two systems out there that are owned and administered by their respective institutions. So as a researcher, I come along, I have some data somewhere on a system, any storage system, could even be something attached to an instrument, which is a very common use case that I'll talk about a lot. And then I need to move it to some compute facility. And I apologize, I should be showing an Argonne resource here. I'm showing an SDSC resource and an old one at that. But the researcher will request the data be moved, and that request is handed off to the Globus service, and Globus will manage it from that point on. It will work through any transient errors on the network and the file systems and so on. So the idea is when you have these large data sets that need to be moved around, you don't want to be wasting time sort of babysitting them, making sure that everything's moved and the integrity is maintained and so on. So you essentially outsource that mundane task to Globus. And it can be done at very large scale. I'll talk about some of the features we have for automating some of these things. So not just sort of ad hoc like this with the browser. Another very important aspect of the service is the ability to share data with collaborators. So if you're working with someone at another institution, they may not have local accounts at ALCF or whatever resource you're using to do your analyses or simulations. And so you may want to share the data, the source data, the products that come out of your analysis, whatever, with those collaborators. So you can do that through the Globus service without having to move the data anywhere special. So what you do is you grant permissions to those individuals or group of individuals to access that data, and you do that in Globus. The data remain wherever they are on that storage system, and then these folks can come along and log into the Globus service and access the data directly. Again, all without having to get local accounts and have all the overhead of managing these temporary accounts just for the purposes of sharing data. And again, this is done all with multiple levels of security. I'll touch on some of those when I show you the system in a few minutes here. So those are some of the core services. We also have a number of other services that allow you to build data portals, science gateways, data commons. There's all sorts of different names, but essentially I think of it as anytime you want to make data more widely accessible and discoverable by the community or by an extended set of collaborators, we provide a number of services for you to do that. And I'll touch on some of those. I've got a couple of Jupyter notebooks. Depending on time, I might poke through some of those and give you an idea of what that looks like. So a lot of some of the services can be accessed through the web browser. Certainly the transfer and sharing, which are the core ones. Some of the others are strictly API based at this point. You have the ability to use Globus against many different types of storage systems. The default is, you have some POSIX compliant storage system that works out of the box, but there's also what we have a set of connectors that allow you to talk to other systems, object stores like S3, Amazon S3 and compatible stores, as well as many others, archival systems and so on. At a very, very high level, this is what the architecture of the system looks like. So we host and operate a single multi-tenant service that's actually lives on Amazon Web Services. We've been based on Amazon since inception of the service, so we've never had any infrastructure, sort of physical infrastructure of our own. So we run everything on Amazon. And as I said, this service acts as, as the control channel to a number of these, what we call endpoints. So these are systems out there that have been made accessible via the Globus service. And we can move data between them, and we can set permissions and so on. I show these two boxes here, the subscriber domain and the Globus security domain. That's because we're very careful to ensure that anybody who's using the service maintains full control over their own local infrastructure, their storage systems. At no point does the Globus service sort of take over or supersede or bypass any of the controls or configurations that are on that system. The Globus client basically sits on top of the storage system and just essentially makes available another mode for accessing the data on that system. And the way we do that is if you want to enable your own system, you can do that. You can actually enable your laptop to be an endpoint. So you download this thing called Globus Connect. It's available for all the major operating systems for personal systems. But the more interesting ones are the server ones. So we have support for various Linux distributions. So a system administrator would deploy this on what we call a data transfer node, and via that data transfer node, they would expose one or more connected storage systems. And from your perspective, from our perspective as researchers, we could those would just look like we're browsing our own local system, and we can move data and share data from any of those. So let me actually switch over to browser to show you that. So this is the Globus homepage, globus.org. When I log into the service, so what we have here as a login mechanism is a federated identity and access management system that we call Globus Auth. So we have a federation of institutions whose identities we trust, or whose identity providers we trust. So if you log in with a credential from any one of those systems, you will be able to access your endpoints without actually having to create a separate Globus username or password, anything like that. So I could log in with, actually let me log in with my University of Chicago. But you can have linked identity as well. I'll show you that in a second. But the login works as follows. So when you try and access that identity system, you get redirected. So you actually authenticate with your own institution. And this is because we don't want to be maintaining people's credentials at any point in time. So I'm actually logging in as I would normally for any other service at UChicago. I just got my two-factor prompt here, confirm that, and I'll get dropped back into the service. So as, oops, I'm not sure what happened there. All right. Maybe a little bit of a lag. I should be logged in though, because I did confirm that. Okay, so so I get dropped back in here, and let's make this a little bigger. So this is our file manager. It's a system browser, storage system browser. So I can look at any system out there that I have access to. There are actually, as I showed on that earlier slide, tens of thousands of systems that are registered and accessible through the service. But just because I can see them doesn't mean I can access them. So I'm going to actually find one. So let me go to a public repository. So for those that are climate scientists, you may know NCAR's Research Data Archive. So NCAR makes available tens of petabytes of climate reference data. So this is one subset of that data that I'm accessing. This actually lives on some system out at in Boulder, in Colorado. Again, this is all sort of opaque from my perspective. I know it doesn't really matter where things live. Globus is just serving them up to me. So let's say I want to remove this data from NCAR to, so I have an endpoint at Argonne on the Petrol storage system. So let's say I want to drop it in here, and I'll just go put it in my directory so I'm not cluttering other stuff. Okay, so actually I'll just make a new folder. Call it ATPESC. So what I'm doing here again is I'm talking to two different storage systems via the Globus interface, and I'm going to move data from one to the other. So let's say, I'm staging some data so it can be computed on. So I'll just select all of these files. I'm not sure what this data is because I'm not a climate scientist, but I'll just fire off the transfer, and you'll see that this request has been submitted. So that means that the Globus service has this request now. It's going to go off and work on it. At this point, I could shut my browser down. I could close my laptop and go home for the weekend. And the transfer would just continue because the data are being moved directly between those two systems. I can go and check on it if I wanted to. So I can click here on the left on activity, and I can look at this transfer, and you'll see it's about 8,000 files that will be moved. So again, pretty, this is actually a couple of terabytes of data. It'll move sort of out there. I don't have to worry about it, and I can go to it later. And now Globus will notify me when it's done so that I can go ahead and run compute or whatever on it. So that's, again, the simplest view that, as far as doing ad hoc transfers. I mentioned the ability to share data. So let me actually switch to a different endpoint. So I'm going to actually go to my campus cluster at U Chicago, which is called Midway. So this is an HPC cluster on campus, and I'm going to go in there because that's a system that I have permissions to share data from. Not all system administrators will allow sharing. Again, there's obviously institutional policies that are in place. So again, Globus doesn't bypass any of those. We simply allow administrators to open things up or keep them closed as they wish. So let's say I wanted to share whatever this data is with all of you. I could create a group to share it with, or I can share with an individual. And so the way I do this is I create what's called a guest collection. As the name suggests, it's granting you access to this collection of data as a guest because you don't have a local account on that cluster. So I can just call it ATPESC share and create that guest collection. And then I can go ahead and grant permissions either to an individual user, a group of users, or I could say, well, actually, this is public data, and all you have to do is log into Globus, and you can access that. So I'll add read permissions. So actually, if you actually go and log into Globus right now, you'll be able to go and see that data set, which actually lives on a system that you don't normally have access to, but with a few clicks, I gave you access to it via Globus. So if I were to look for it here, I'll see that data. And for some folks that who get nervous about sharing data rest assured that you can lock this down in a very fine-grained manner. So you can see how I can't navigate up or out of this folder. All I can see is the data that's in here. So that's the sharing. Again, just a quick glimpse of that. So that's all well and good, but a lot of the time, ad hoc is just insufficient, and certainly in exascale era, it will never be an ad hoc sort of point and click. You can't do that at scale. So we also make available other interfaces. There's a command line interface that you can use to script things. So this is just it's a set of Python tools that you install. It uses the same authentication and authorization mechanisms through this Globus auth service. And you can do everything I just showed you in the web browser, as well as a lot more, because we don't expose the full functionality through the browser, the web app. There are additional things that you can do via the command line. So this is useful if you have jobs that are being submitted and you want to sort of inline with whatever resource manager you're using, resource scheduler. You can stage in as part of your staging command. You can call out, launch a Globus transfer, and then when the data gets in there, then you can run the job. And then when it completes, you can again call out to Globus and launch a transfer to move the results perhaps somewhere else. Perhaps share it with someone so you can change access controls and make it available to the other people working with you, or someone at another institution, what have you. So all this can be automated through the command line, and that's again adequate for in some scenarios, but even that may not be sufficient. So the case that we see more and more is folks working with data off instruments. And honestly, this I think is going to basically drive everybody to automate things. Otherwise, they'll never be able to cope. Even though some things can be done at moderate scale today, I think a couple of years from now that will no longer be the case by and large. So our friend the ATPESC is here. That's one group that we've worked with. We worked with a lot of beamline scientists to automate their flows. One such example
Voss?
Yes.
Sorry, we have a question from Slack from Julio. He wants to know if Globus is ITAR compliant. I'm not familiar with that myself, so he may have to expand on that. If
it is not ITAR compliant, we do have an additional level of security that we provide, what we call the high assurance level. So certain folks can opt for that, but that gets you compliance with NIST 800-171 and NIST 853 low, if you're familiar with those. But we do not have, we can't be used for with ITAR data. That's something that we're looking at. We're also looking at, in case someone is wondering about things like CMMC, we are looking at, we're actually right now doing we have some funding to do a gap analysis to see if we can be CMMC certified, which is the standard that's being put out there by the DoD, which I think is actually going to be adopted by a lot of other federal agencies. So we may at some point be compliant to that. Right now we are not, but we do have the ability to sign BAA, so we can be used for managing data in a HIPAA aligned way if you're working with personal health information and so on. So we do have some levels of additional protection, but not ITAR specifically.
Okay, thank you.
Sure. Yeah, please interrupt me with other questions. I can't see the chat. I'm sure there's a way I can pull it up here, but let's see. Anyway, just let me know if there's other questions. So yeah, so one example of many where the sort of the point and click or even the scripting mode really isn't sufficient is running experiments at a light source like the ATPESC. So this is an example for XPCS is the X-ray photon crystallography. So the scientists are running putting material samples through a light beam and they're acquiring some data that they then send back to the ALCF, where they run some codes to do, it's a sort of a correlation of time series of images that they're taking of those samples, and generating plots of the results. And then they are taking those results, moving them to another system called Petrol, where they're annotating them with certain metadata, and then making them available through by generating a search index and making them available through a portal where other folks can come along and use them in their own downstream analyses or what have you. And this is a very common design pattern that we see. We expect when exascale compute resources come online. I really think that any experiments running exascale compute codes will need some level of this type of automation to handle both data coming in as well as data coming out, and organizing it in automated fashion. Otherwise, it's an untenable problem, I believe, to sort of make this stuff more widely accessible. So one example of this, of that type of data portal that I'll show you quickly is at the LCF. Actually, it's called Petrol Data. So I will go there, Petrol Data.lcf. And you folks can access this as well. So it's a public website, but you can't necessarily access all the data sets. So this is a common repository of a number of different projects that you can see here. And some of them are available to anyone. You just have to log in. Others, you have to request access. So when I log in here, it actually uses Globus Auth, the same service that I logged into the Globus web app, except this time it's asking me to grant access to allow this portal to access Globus information on my behalf. So I'll consent to that. That consent screen, by the way, is no different than what you have probably seen if you use Google or LinkedIn or Facebook or whatever to log into other services where they say, log in, sign in with Google. Same idea, you grant consent to that service to access your profile on those other services. So I'm logged in here, and I can go look at, I'll just pick the, I don't think I have data to XPCS, access to the XPCS data. So I'll pick the MDF, the materials data facility. This is actually a pretty nice, pretty extensive set of data. You can see they've got almost 1 million records published out here. So this is a set of curated data sets that are described using various metadata here. So I can sort of point and click and narrow things down to, based on whatever I'm looking for. And then when I want to actually get the data, I can click on the Globus link and it'll drop me into the Globus application. And then, well, I guess I don't have permissions on that for some reason. So maybe that's been restricted, but then I would pick the target and then move the data, and off we go. So that kind of portal is really becoming much more commonplace, again, just because it's really, really challenging to make these big data sets available. You may have heard the term FAIR, findable, accessible, I forget what the I stands for, reproducible, I think it might be identifiable. And so we try and make it easy for researchers to add fairness to their data. So in that flow that I just, that high level flow that I showed you, there's a number of these platform services in Globus that come into play. There's the auth service, which I've talked about already. There's transfer and sharing. There's also the Globus search service, which provides a means for capturing metadata to describe a data set, and then creating an index and presenting features or facets extracting features and presenting them as facets for you to search on and do some of that filtered search that I just showed you in the MDF data portal. And then there's also a service called the Globus Flows service. I've got all of them listed down the bottom here, that allows you to sort of hook all these things together and let this thing run essentially like a workflow. You know, I'm sure most folks are familiar with workflow engines. So you can think of this as a data flow automation engine. So we have that services available as well. So I'm going to talk a little bit about each of these services. Again, I'm covering a lot of ground here. It's sort of it's akin to one of these billionaires going to space. You know, you get a taste of what space travel is like, but you really won't know what it's really like until you've tried it yourself. But I'm going to try and give you a little bit of a taste of all these different pieces and show you how you can hook them all together. And perhaps some or all of these will be relevant in your own work going forward. So, so I mentioned the Globus Auth service. This is, so we don't run our own identity service. As you saw there, I had, when I logged into the Globus web app, there were literally 1,000+ institutions listed. So we act as a broker between those identity providers. They can be, you know, enterprise auth systems. They can be local authentication systems that you set up on your own cluster. It really doesn't matter. As long as they're trusted by Globus, they can be used. The service can also be used to broker authentication and authorization between applications, other applications that you develop. So you saw an example of that in that portal, where, you know, that's not a Globus hosted portal, that's run by the ALCF, but it actually uses the Globus Auth service for people to access it. And you can also even use this to broker identity authorization flows between two different services. So if you have a system that's calling another API, another service with its own API, you can actually enable that API to use Globus Auth, and you can have it all kind of working seamlessly on the back end. Everything in this Globus Auth service is standard OAuth 2. If you're familiar with that, OAuth is really sort of emerged over the last few years as the de facto way of doing web-based authorization and access control. There's an associated standard called the OpenID Connect standard that applies to identity providers. So we use both of those. So if you have systems that are compliant with those, you can sort of plug them in here. The way that you access any one of these services is by first registering with the Globus service itself with Globus Auth. So what you do is you go ahead and register a client, an OAuth client. You tell it what scopes, in other words, what parts of the service you wish it to have, you wish to grant access to, and you will get back a client ID and secret. And then you use that pair of credentials in your own application to call out to the Globus service and also to call out to other services. So the way that works is, in one example, and I'll actually show you this in Jupyter Hub in just a second. So if I have a Jupyter Hub acting as a client, I want to access a notebook. I go and try and access that. I get redirected via the browser to Globus Auth, and from there Globus Auth sends me out to the identity provider. You actually saw me doing that when I was logging into the Globus web app. The same thing happens if you're doing it through your own application. So I would go to UChicago or Argonne's identity system, log in there, assuming that succeeds. Globus Auth then generates this thing called an authorization code. That's the second leg of the flow. And then the third part of the flow is the service will turn around automatically in the background, send that flow, send that code together with its client ID and secret back to Globus Auth, and then Globus Auth will generate an access token that it then gives back to the application. And now the application has this essentially this temporary credential. It's an opaque token that it can turn around and use to call one or more services on the Globus platform or on other applications that use Globus auth. And it can call services and take action on those services, again, based on the scopes that were requested, the access scopes, and obviously assuming the user consented to Globus accessing those scopes. So that's, again, this is maybe a little more that detail than you need to know at this point. Suffice it to say that there is an authentication authorization mechanism that's standard, and you can access this through any number of libraries that are out there. Google has an OAuth library, as do many other providers, as do we actually in our SDK. And speaking of which, there's the SDK actually provides clients for talking to a number of different services. So for example, if you want to talk to the transfer service and do some of the transfer and sharing tasks that I showed earlier, you would import the transfer client, instantiate one of those transfer client objects, and then you can call various methods on that object. And I've got links throughout here. I haven't shared these slides yet. I'll send them to Rob and Co for posting shortly. But all of this information is available on our. We have a public GitHub repo at github.com/Globus, and also if you go to docs.globus.org, there's lots of reference there. So so let me actually show you what this looks like when you're talking to some of the Globus services. So I will go to jupiter.demo.globus.org. And by the way, you can actually also access this Jupyter Hub. It's open. The only thing it requires is that you log in with a Globus identity, trusted identity. So you can use your Argonne account and just log in here, and it'll spin up your own little Jupyter server, and then you can access these notebooks. So we've got a number of notebooks that we've created over the last few years for demonstrating some of these APIs. I'm going to pick on this one here. This is just an introductory notebook that walks you through a lot of the basics of using the Globus platform. So I'm going to run through this, and I'll talk about what I'm doing. But mostly, I want to highlight some of the things I talked about here on the authentication side. So first off, I'm just going to set a couple of variables. Actually, I should point out that when you're using the API, and actually when you're using the command line as well, you do need to identify the resources that you're working with by their UUID. So every resource in Globus, every endpoint, every collection, even every user permission, all of these are sort of first-class entities that have their own unique identifier, and that's how you access them through any of these other interfaces. So down here, what I'm going to do, the first thing I'm going to do is actually, so I imported Globus SDK. This client ID is the client ID of this Jupyter Hub that I'm running. So that's just hardwired in there. But normally, if this were your own application, you would give it your own client ID secret. So I'm actually going to kick off an authorization flow. So that happens right here. So I call this OAuth to start flow method, and it says to me, okay, go ahead, click on here to log in and get get an authorization code. So I get redirected to Globus auth. I log in here and I give it a label for reference. So what I'm doing here is I'm granting consent to that Jupyter notebook to access various services on my behalf. So I'll take this code, come back in here into my notebook, paste it into here. And now when I run this, so this is that third leg or that second leg, I should say, of the flow that I showed you in that diagram with the arrows going back and forth. When I run that, I go and I exchange that code for tokens. That happens right here. So I come back and I have a set of tokens. In this particular request, I asked for a token, two sets of tokens to two different Globus services, to the Globus auth service, which lives at that endpoint, and to the transfer service, which lives at that endpoint. And here you can see my access tokens for each of those. And just, as I said, just an opaque string. So now this notebook as a client application, and this again could be any application that you've written, can turn around and call the Globus service on my behalf and do various things. So, oops, I ran that by mistake again. So I can run the help command. That's a very simple one. I can go and check on the status of an endpoint. Oop, and I apologize. I do have to take care of that. Give me 1 second. Fortunately, he still hasn't figured out how to open the door. So this is again here. I'm calling the transfer service API, and I'm asking it for to get information on a given endpoint. So here's all the attributes related to that particular resource. Most importantly, for these resources, what I care about are things like the ID. I may care about a display name, so I can actually, that would be the name I would see, for instance, in the Globus web app, if I were to go and access it and so on. So I'm not going to go through too much more of that, but there's a whole bunch of other examples here calling out to the service to search and find endpoints, to actually fire off a transfer, and so on. Okay. So in a lot of these data flows, what we end up doing is taking data from an instrument or from some source system and moving it somewhere else, and then granting permissions to someone or a group of others. And so all of this can be done through through the API, as I said. And if I go back to that example portal that I showed you, that gets done in the background. So the data for some new experiment will get pushed to the Petrol storage system. But then at that point, it's just a bunch of files, and without any additional sort of description or metadata, they're relatively useless to anybody other than perhaps the creator. So that's where another one of the services comes into play, and that's the search service. So Globus Search allows you to associate metadata to essentially create an index with whatever metadata you choose. So we don't have any prescribed schemas or ontology, metadata ontology, or anything like that. You simply say, here are the attributes that I want to store related to this data set with their respective values. You actually pass it to the search service as a JSON document, and that gets pushed into an index. And we use Elasticsearch, just FYI for these indexes. So you can push the data in there. So an ingest call would look something like this. You tell it the ingest type is gmeta, so this is Globus meta list. It's our format, and then here are the data. So I can put in an ID, subject. Again, whatever is in here is really up to you. So you push that out to the Globus search service, and you can also restrict, and this is actually a very critical point, if you're working with protected or restricted data in some way, you can actually restrict access to the search index results based on a user or user group. So just creating this index by default, it becomes available for anybody who's granted access to it through Globus, but you can further sort of narrow that down. So in this case, I'm saying, hey, restrict this to this specific identity. So in this case, only this person or this individual, whatever this UUID refers to. I don't know if it's a single user or a group or even an application, right? So you may be doing some filtering within your data portal or your other application on the results before presenting them to the user. So you want to prevent users perhaps from talking directly to the index. So in this case, you might restrict access to the metadata in this index to just your application. And when someone runs a query, they do it only through that app, and so you have much tighter control. So lots of different ways, again, that you could architect this. But the important point is that there is a very scalable service on the back end that you can drive data into and then query. And on the query front, we actually provide two different mechanisms for querying. So the simple query is simply by adding URL parameters to your request. So you fire off a GET and you tell it in your query string here, whatever attributes you're looking for. So that will just go and do a normal GET on that index and return whatever results it found. But a lot of times, especially if you have a very rich metadata schema that you've associated with these data sets, you might want to do more complex queries. In this case, you can actually post a search query document to the service, so you can actually give it a set of filters and a set of facets, and collectively those will be evaluated against the index, and you'll get some result back. Oops, now I'm going to pause there and I'll show you. I'll go back to my notebooks here and show you what that looks like in one of these notebooks. So we have this metadata search and discovery. So this is again another notebook you could just run through just to give you an idea of how the service works. So what we've implemented in this notebook is again, we're going to authenticate. That's always a starting point. So we authenticate with the Globus service. We get back some credentials. We're actually going to move some data to an endpoint and set an access control rule, give permissions to this system so that we can actually access it through the search service. And then we're going to put some data, associate some metadata, and then push it into the search index. Oh, and we'll also have the ability in here to mint persistent identifier. In this demo, I think we just mint minutes, but in a more sort of production setting, you might be, if you're publishing some data, you might be minting a DOI, through your institution, and associating that with the data set as one of the search attributes. So the first part of this again is just accessing Globus to get some tokens. So in this case, I got another token to talk to the transfer service, but I also got tokens for the search service right here, and then for this other minute app that I'm gonna call out to. So I've got some commands here that where I assemble the data that I'm actually going to sort of publish out there. So I'm calling the transfer client. In the other notebook, I showed you how you could just call it to get some info on an endpoint. Here I'm using it to create a directory on some endpoint out there that I've designated as my target system where I'm going to publish this data. And then over here, I'm actually going to initiate a transfer to move some data. So I'm going to transfer the files and wait till they've completed. So I should get a confirmation. This is actually just transferring just a single text file, just a little file for demo purposes. So I've pushed some data out there. And again, think of this not just as me clicking on different steps here, obviously, but sort of I want you to envisage this as an automated flow that's running. So maybe this is one of many thousands of files that got generated as part of some run on a beamline or on a cryo-EM microscope or what have you. And now it gets, each of these files gets pushed out to this endpoint, and I need to make that data available to others. In this case, everyone that will be accessing my data through this portal. So I might set access to a specific group. So in this case, I have a tutorial users group that I'll do for this purpose. So I said, I'll move the data and said anybody in the tutorial users group can access this data. Oops, I just ran that again. And now I'm going to add some metadata. So this is where I define whatever data I wish to put into the search index that will then be used to present facets for me for doing queries on the index. So I've just put some random data here, title, contributors, etc. So do that. As I said, I'm going to create a persistent identifier, but don't worry about that. I mean, that's not necessarily a requirement. It's just I have that in here for demo purposes. So I've generated a minute. So now I'm going to go ahead and push all of this data into the index. So this is where I do that post. So I call this this endpoint. It's just a test endpoint. That's why it's beta/index. And I pass it this index doc that I created, and all of the data with it. So, oops, did that. Okay, sorry, that was just to get the index. My apologies. I got the index. So here I'm actually doing the ingest of the data. So what comes back is essentially plays back to me what was pushed into the index. So this is the subject. This is the actual target file, or the metadata the actual data set that I'm pointing to, and then this is all the metadata that I just associated with it. And so at this point, I could go ahead and run a simple query that says, get me everything that has, I don't know, John in it. Actually, maybe I'll just try Rob. I think I put Rob's name in there. So we'll get back that data set that we just published. So this is essentially what's going on behind the scenes in that Petrol data portal that I showed you earlier. And again, it's all being automated because, you know, when you've got an image coming off an instrument every few seconds, it's not tenable to run these things on your own. So and on that note, the last service I'm going to just touch on briefly is this thing called Globus flows. So this is means for orchestrating these various tasks and creating these flows, which are basically an encapsulated set of actions, states basically that the data go through, and having Globus run these for you automatically when certain events happen. So so you define the flow as a series of actions, and each action uses what we call an action provider to perform some task. So we have an action provider, for instance, to talk to the Globus transfer service. So down here, if I have a transfer action or a series of transfer actions, it will use that action provider to submit a transfer request to Globus. If I were to call if I wanted to talk to search and do an ingest, I would call the search action provider and request it to ingest some metadata and so on. These flows can be initiated by triggers. This is something that's still in development, so I'm not really spend time on it. But I do want to show you. Let's see how we're doing on time. Okay, we've got a few minutes, and I'll leave time for questions. I do want to show you what this looks like from the perspective first of an end user. So if I go to my flows console here in the service, what happens is using the flow service is sort of in two parts. One is someone builds and deploys the flow. You might do that, you know, up front, typically before you start running an experiment, and then every time you run a new experiment, that flow would just be called automatically. So I've got a library of flows here I don't know which ones. I don't really seem to have too many of mine. Okay, so here are some tutorial flows that I've created. So I can go ahead and look at what this looks like right now. This is, it's all the JSON is all there in its raw glory. We are actually in the midst of adding some sort of nicer GUI facades on this, so you don't have to necessarily deal with all this JSON. But again, this is just the definition of a flow. Here you can see this flow has two actions. One is to move files right here, and the other one is to set permissions on that target directory. So essentially the same thing I was talking about earlier, except it's just encapsulated in this flow. So what I could do is, once this flow has been deployed, I could start the flow. And again, I have to grant permissions to this flow to actually use my credentials to access various Globus resources. So I could have that run. Actually, I need to give it some input here, which I'm not going to bother with because I don't want to tinker with JSON right now. I put the inputs that are required. I'd start the flow, and then I could go and monitor that in the activity here. It would tell me the state of the flow and so on. So I could see everything that's going on, you know, every event, you know, transfer succeeded, et cetera, et cetera. So again, sort of going through this pretty quickly, but the idea here is that when you have data management requirements at the scale that we see in exascale computing, this is the kind of this is one example of a tool that you can use to sort of fire and forget things, right? So you set them up once, and then you have things that applications or scripts or whatever that fire these things off, so that you can run them at scale. I think that's all I want to cover. I could dive into more notebooks and things or whatever you guys like, but let me just pause there. We have about 5-6 minutes for questions and see if anybody wants to ask anything. And I know it's Friday afternoon, but I'm sure someone has a burning question somewhere. Okay, maybe not.
No.
Okay, well, thank you again. As I said, a lot of what I showed you is, you know, it's open, it's out there, it's available. You can go to our website, check things out. You can actually access this Jupyter Hub and play around with the APIs before you sort of build them into your own flows and so on. Okay, Rob, back to you.
Thank you very much for that tour of Globus. And